Hi there, thanks for clicking on and watching. Welcome to this video. Going to go through some more questions that I've selected to help with revision for the pure part of Maths A Level for 2023. So let's get started then, and in this video I've selected a range of problem solving modelling type questions. These are the questions that pupils find hard, and if you remember from video 1, up to 27% of the exam can be asking you to problem solve, up to 27% of the exam asking you to interpret your answers, and the rest of the exam skills and techniques that you can revise and prepare for. But it's a good idea to work through these type of questions even though you won't get the same modelling situation again. The questions kind of flow in a similar way, so it's a good idea to just do as many past papers as you can to prepare for the exam. So here we have got a trig expression, and we're being asked to put it in terms of a single trig ratio, cos. So on the formula sheet you get that cos of A plus or minus B is equivalent to cos A cos B, and then it's minus plus sine A sine B. Now we're being asked to use this expansion where A and B are going to be our theta and our alpha. We can see we've got an R in front, so if I put an R there, I will have to put an R in front of each of these. So we're going to set up the expression and write it in this form. So 5 cos theta minus 8 sine theta, we can say, is equivalent to R. Now A and B are our theta and alpha, so it's going to be cos theta cos alpha minus R sine theta sine alpha. Now the way cos expands with that plus there, so plus here, it has the minus. This is the way it's going to set up because we've got a minus here and a minus here will already be taken care of. So what we do now is we equate coefficients, and we can see there's a 5 being times by cos theta. What is being times by cos theta on the right now is R cos alpha. So we can write that 5 is equal to R cos alpha. Similarly, the 8 is being times by sine theta, so 8 is equal to what's being times by sine theta? It is R sine alpha. Now what we do is we need to find R and alpha. They are constants. The theta is going to vary, but what we do to find R is we square both sides and add, so squaring on the left and squaring on the right and adding that. On the left, you're going to get 25 plus 64 is equal to, and I can take R squared out as a common factor, cos squared alpha plus sine squared alpha, which we know is equal to 1. 25 plus 64 is 89, which is equal to R squared. So R is equal to the square root of 89. So we've found R. Now we need to find alpha. Now we go back to these equating coefficients equations without the fact that I've written squared on them. If we do the sine equation over the cos equation, we're going to get R sine alpha over R cos alpha. That must be equal to 8 over 5. So the R's will cancel. Tan alpha is equal to 8 over 5. Tan to the minus 1, inverse tan of 8 over 5 is equal to 1.0122, and that's equal to alpha. Now we must have our calculator in radians because we've spotted up here that we're working in radians because alpha is between 0 and pi. So rewriting our expression in the form that we've been asked, it's going to be root 89 cos of theta plus 1.0122. Now, the way these questions work, you're usually given a situation now that involves what you've already worked out in part A. And we can see that in part B, this equation here is modelling the temperature of a kiln, 1100 plus 5 times cos of an angle minus 8 sine of an angle, which is exactly what we've been working on in part A. There's a typo here. It should be that X is varying, where X is the hours that the pottery is in the kiln, and we can see it's in there for 3 days. So part B is asking us to calculate the maximum value that t can predict and find the time when this occurs. So instead of having t written in here, because we've just found that that can be expressed in this single ratio in terms of cos, we can rewrite that t is equal to 1100 plus, then the 5 times the cos of the angle is going to be root 89 cos. Now it was theta in part A, but the angle is now x over 3, so we need to change that, x over 3, then the alpha is still the same, 1.0122. Now, this equation is going to be influenced and governed by the fact that we've got cos. We can't change the 1100, but what is going to give it its maximum, if we think about the cos graph goes from 1 to -1, and it can't go above 1, so all of this part is just going to vary between 1 and -1, and to give it its maximum is when it's going to be 1, so the maximum temperature this can be is going to be 1100 plus root 89, which comes out to be 1109 degrees C. So we're also being asked for the time that this happens. So that's going to happen when the angle of the cos is going to equal where the cos graph goes to its max, which is either at 0 or at 2 pi. So we need to write that x over 3 plus 1.0122 must equal 0 or 2 pi in order for that angle to be taking the cos of it to get it to its max. And we can see if we start to unravel and get x on its own, we're going to be taking that 1.0122 over, and that will cause us, if we use the 0, to get a minus, and x is starting between 0 and 72, so it's in there for 3 days. We don't want to get a minus, that's not possible, so we can't use the 0, we'll have to use the 2 pi. So x over 3 plus the 1.0122 equals 2 pi, and then if we just unravel that, take the 1.012 to the other side as a minus, times up by 3, x comes out to be 15.81, and that will be in hours. Now in part C, we're being asked to calculate the times during the first 24 hours where the temperature is predicted by the model to be 1097. So if we set up that 1097 is equal to our 1100 plus the root 89 cos of the x over 3 plus the alpha, then all we need to do is unravel for that x. So you're going to take away 1100, and then you're going to divide by root 89, and then you're going to do inverse cos. So you're going to be doing cos to the -1 of minus 0.317999. That's what you get when you do 1097, take away the 1100, divide by the root 89, and that gives you an angle of 1.8944, and that is the same as this angle here. But before we start taking off the 1.0122 and divide by 3, we have to think about the cos graph, because there'll be other places on the graph where it also equals that angle. So in one period 0 to 2 pi, the minus 0.317999 is here, the 1.89 there, and then we use the symmetry of the graph and come back from 2 pi to find that there'll be another place that gives us that. So you need to do 2 pi minus the 1.8944. Now we're going to be timesing by 3, so just in case within this time period of 0 to 72 hours there is another one, we'll have to go around another period and go 2 pi plus, because that will also give us a cos of minus 0.31799. So if you do 2 pi plus that 1.8944, Now to all of these angles, they are the same as the x over 3 plus 1.0122. To each of these three answers, we need to take off the 1.0122 and then times by the 3 to get x on its own. And if you do that, x comes out to be 2.65 hours, 10.13, or 21.5. So going that extra one, this one is also within the 24 hours. This next question is a numerical methods question. We've got a function h of t, which is modelling the height of the rocket t seconds after the launch. Now, I wouldn't really know what the graph of this looks like, but for part A, we're being asked to show that the rocket returns to the ground in this time interval between 19.3 and 19.4. So at 19.3 and 19.4, returning to the ground, we are going to be looking for a change of sign. So all we need to do is do h of 19.3. So if you put t in as 19.3 into the function, out will come 0.975, and then we do the same with 19.4, and we get minus 0.393. Now the function is continuous across that interval, and we have a change of sign. Now to get the 2 marks, we must say that the function is continuous. And then how do we write that it's continuous across that interval? You can use the interval notation, which is these square brackets. That means it's across that interval between 19.3 and 19.4. In part B, it's asking us to use t0 as 19.5 and apply the Newton Raphson to get a second approximation to the root. So you get the Newton Raphson formula in the formula book. It tells you that x1 is the previous one minus f of x0 over f dash of x0. So we've got x is t and f is h, but we're still going to have to find the differential. So h dash of t is going to be the 40, which is just going to join in. The ln will differentiate to 1 over, so it's t plus 1. Plus the 40 will join in again, and we'll get the differential of sine, which is cos. We can leave alone on the inside because we're applying the chain rule, just differentiating with respect to sine and getting cos. And then because we left alone on the inside, we then have to differentiate with respect to t over 5, which will just be a fifth, which can go on the front. And then it's going to be minus 2/4 t. And if we just tidy that up, it'll be 40 over t plus 1 plus 8 cos of t over 5 minus a half t. So that is the differential. Now being asked to put t naught, which is going to be our x naught, as 19.35. So t1 will be 19.35 minus h of 19.35 divided by h dash of 19.35. So on your calculators, if you put in 19.35 and press equals, then your calculator will hold that at the bottom right of the screen, and you can just use the answer key. So you can feed these functions in, but wherever you want to put t in, just press answer, and then what you can do, you can get your first approximation, which is going to be your t1. Now if you do all that, it comes out to be 19.35 minus 0.2903 over minus 13.6792. And if you keep pressing equals, I mean, you'll get the first approximation t1, which is going to be 19.371. But if you do keep pressing equals and you've used this method of using the answer key on your calculator, the Newton Raphson method does settle down to the root, and it does stay at 3.71 fairly quickly. So that is to 3 decimal places the approximation to the root. In part C, we're asked to consider our answer in part B and choose an appropriate interval to then say that this is the best estimate for the root. So what we need to do is look at our answer from part B, which is 19.371, and look at the upper and lower bound. So if you just go to the next column along, the upper bound is going to be 19.3715. The lower bound is 19.3705. And if you do H of these two, you'll again get a change of sign in that interval, and therefore we have found to 3 decimal places the best estimate of the root. But of course you need to also say again that the function is continuous over that interval. This next question is a binomial expansion question, and we've got this fraction, which I'm going to rewrite as 1 plus x times the 1 minus 2x to the minus. We'll put that denominator in the numerator position, and then the square root I can write as a half. So we're going to use the binomial expansion to expand that, and you get in the formula book that 1 plus ax to the n is equal to 1 plus nax plus n times n minus 1 over 2 factorial ax all squared plus dot dot dot, and we're only after the terms up to and including the x squared term, so we don't need any more than that. So we can rewrite that 1 minus 2x to the minus a half, n being minus a half and the a being minus 2 is going to be 1 plus n minus a half minus 2x plus n minus a half, and then we have to take 1 off. If you're at minus a half and you need to go down a whole one, that's going down 2 halves, so that will be minus 3 over 2, and then we'll have minus 2x all squared. That's over 2 factorial. So let's tidy that up. It's 1, and then the minuses here will cancel, the 2's will cancel, and we'll just have plus x. Here the minuses will cancel, and you'll get 1 times 3 is 3 over 2 times 2 is 4, so that's 3/4 divided by 2 on the bottom, which will give you 3/8. So that will be 3/8 times the minus 2 all squared is going to be 4x, so that's going to be 3 times 4, which is 12. 12 divided by 8 is plus 3 over 2x squared. Now we need to join the 1 plus x, the numerator, in, so it's going to be 1 plus x times the 1 plus x plus 3 over 2x squared. And remember that we're just after up to the x squared term, so we're going to times that 1 into each of the terms, which will give us just that second bracket repeated, 1 plus x plus 3 over 2x squared, and then we're going to times the x in, but I'm not going to times that final one because you're going to have x times x squared, which will give me an x cubed, and I don't want any terms after the x squared. So we're just going to have to times the x by the first 2 terms, so that's plus x, doing that one, and then plus x squared. And then if we just collect like terms, you're going to have a 1, and then plus 2x plus 1.5 x squared plus another whole x squared. That whole x squared is 2 halves, so altogether it's 5 over 2 x squareds. So that's part A. Part B, state the set of values for which the expansion is valid. Well, it's going to be valid as long as that 2x, the mod of that is less than 1, which means that that 2x has to lie between minus 1 and 1, and then just solving and dividing by 2 on both sides, x will have to lie between minus a half and a half. Then in part C, show that when x is 1 over 100, the value of this fraction that we had at the beginning is this. So it's not asking us to put the 1 over 100 into our expansion, it's asking us to put it into this fraction. So you're going to have 1 plus 1 over 100, all divided by the square root of 1 minus 2 times 1 over 100, or 2 over 100. So on the top, that whole one is going to be 100 hundredths plus another 1, so it's 101 over 100 divided by, now this is a whole one, minus 2 hundredths, which is 1 50th. So a whole one is 50 50ths minus 1 50th is going to be 49 over 50, and we need to square root that. Now that's quite nice because 49 is a square number, so this is going to be 101 over 100. Now you don't like having fractions in fractions, so if we say that's divided by, and then this 49 over 50, we can put the root, separate the roots, so that's going to be root 49, which is 7, and then 50 is 25 times 2, so the 5 will come out, be 5 root 2. Now when you're dividing fractions, you're going to KFC, keep, flip, change it to a times and do 5 root 2 over 7. The 5 goes into itself once and into that 20, so then we're going to times across the top, 101 root 2 over 20 times 7, which is 140, which is what we're after. Now having a look at part D, and in part D you are asked to substitute 1 over 100 into the expansion this time. So our expansion from part A was 1 plus 2x plus 5 over 2x squared. There would be other terms, but putting x in as 1 over 100 is going to be 1 plus 2 over 100, which is 1 over 50. And when you square 1 over 100 and times it by 5 over 2, that comes out to be 1 over 4,000. Now we can say that's approximately equal to the fraction, and when we put x equal to 1 over 100 into that fraction, we've just found out that it was the 101 root 2 over 140. So we can say that they're approximately equal to each other. Now all we need to do is find out what these three terms add up to, and then just cross multiply. So if you put all that in your calculator or get common denominators and add them up, you'll get 4081 over 4000. It's approximately equal to the 101 root 2 over 140. All we need to do is cross multiply now. 4081 times the 140 divided by the 4000 times the 101 will give us an approximation to root 2, and then if you put all of that in your calculator, you'll get that root 2 is approximately equal to 5 decimal places, 1.41421, which is a good approximation. Here's a question on exponential modelling. We've got the value v of a vintage car t years after it was first valued on the 1st of January in 2001 has got this equation here. Given that the value of the car was 32,000 1st of January 2005 and 50,000 in 2012, find p to 4 decimal places and show that a is 24,800 approximately. So put in parts A, I and II together, you've got two unknowns to find, the A and the P. What do we need to do when we need to find two unknowns? You're going to do simultaneous equations. Now, we're not told what it is at the start, but we are told in 2005. You have to be careful here because the T is not going to be 5. If you think January 2001 is year 1, then 2, 3, 4, 5, it's going to be when T is 4. So we can write that 32,000 is equal to AP to the 4, and then similarly 50,000 is equal to AP to the 11. So when we're in 2012, it's going to be 11 years after 2001. Now what we can do is here is divide them. So 50,000 divided by 32,000 is going to be AP to the 11 over AP to the 4. Now by doing that, the A's will cancel. We just take the indices. So p to the 7 is going to equal this fraction here. And then if we just do 50,000 over 32,000 and take the 7th root of it, that will equal p. In order to get p on its own, when we've got p to the 7, you need to take it to the 7th root, and then that will give us p. And if you do that, p comes out to be 1.0658. Now we need to go back into one of the equations and find a. I'm going to go back into the top one. 32,000 is equal to a times 1.0658 to the 4, and then just divide. A comes out to be 24,796, which is 24,800 approximately. So we've got that answer there. Now part B, with reference to the model, interpret A. Well, A on the front, when t is equal to 0, so we've got v is equal to a p to the t. If that t is equal to 0, then p to the 0 will equal 1. So at time 0, which is on the 1st of January 2001, it's telling us that the value of the car was just going to be a. So the constant a is the value of the car, 1st of Jan 2001. Now the value of the constant p, if we're doing 24,800 times 1.0658 to the t, then this is going to be the rate of increase. If you remember when you did compound interest, if you're going to add on 6%, you would times by 1.06. So the p is proportional to the rate of increase. Now, I saw a question the other day that said instead of interpreting just a and p singularly, it said interpret the constant AP, the two of them times together, and that is AP. And if you can think, there's no power on the t because t is 1, the interpreting the constant AP, the times in those together, that's the value of the car after 1 year. So that was something that caught a few of my students out. They didn't realize that t was just going to be 1. Anyway, you're not asked that in this question, but then for part C, using the model, determine the first year when the value exceeds 100,000. So we want 100,000. We want our value to exceed that, so we need to have the inequality that way. And the putting in the AP to the t is going to be 24,800 times the 1.0658 to the t. Now we need to work out that t. Whenever the unknown is in the power, you're going to be taking logs, but first of all, you need to divide by the 24,800 and then take logs to both sides. You're going to get a log of 125 over 31 needs to be less than t log of your 1.0658. And then if you just divide by the log of 1.0658, then you'll get that 21.88 has to be less than t. So t, the first year to exceed, is going to exceed the 100,000, is going to be above the 21.88. So t equals 22 years. So finding the year, that is going to be 20,023, so this year. Next, we've got a partial fractions and integration question. We've got this equation here where p and q are constants. It passes through 3.5, two vertical asymptotes at equations x equals 2 and x equals -3. Now, where do the vertical asymptotes occur? When you've got a reciprocal type of graph, the vertical asymptotes are where the denominator equals 0. And we can see here when we put x equals -3, that second bracket is going to be 0, and that gives us the vertical asymptote. But when x is equal to 2, then we're going to have a 0 on the denominator. And where's that going to come from? 2 times 2 minus q must equal 0. 4 minus q is equal to 0. So 4 is equal to q. In part 2, we've got to show that p is equal to 15. Well, we do this by putting this point in when x equals 3, y is equal to a half. So a half is equal to p. When x is 3, that's going to be 3 times 3, so that's minus 9, over when x is 3, double 3, 6 minus 4 is 2, and 3 plus 3 is 6. So then we cross multiply, we're going to get 12 is equal to 2p minus 18. So just take that over. 12 plus 18 is 30, is equal to 2p. P is equal to 15. In part C, we're being asked to show that the area of R is A ln of 2, B ln of 3. And A and B, we are told, are rational, which is a clue that we are going to be looking for fractions. If it says integers, you're looking for a whole number, but when it says rational, you're usually looking for fractions. So what we're going to do, we're going to be integrating between 3 and the upper limit there that we don't know. And we're going to be feeding in this function and integrating to find the area under the curve. So the first thing to do is find the upper limit. Now what's happening here when it goes through the x-axis? On the x-axis, y hasn't gone up or down, so here y is equal to 0. So 0 is equal to our 15 minus 3x over the denominator, and it doesn't really matter what's in the denominator. When we cross multiply, the only way that the fraction can equal 0 is when the numerator is 0. So 15 minus 3x equals 0. 15 is equal to 3x, so x is equal to 5, and that makes sense with the graph that we're going to be integrating between 3 and 5. Now what we need to do is look at the thing we're going to be integrating. You can't integrate it as a single fraction. You need to split it up into partial fractions. So we've got 15 minus 3x over our 2x minus 4x plus 3. We're going to set that up. It's going to be a over the 2x minus 4 plus the b over x plus 3. We're going to go clear of fractions and multiply by that common denominator. So I've just written it there. That's that common denominator here. You can see it's going to cancel with everything on the left, but the 2x minus 4 will cancel and the x plus 3 will cancel. So you're going to just get left going clear of fractions with 15 minus 3x is equal to a with the denominator it's not got plus b with the other one. And now we let x equal values to make those brackets 0. So with x is equal to minus 3, you're going to get a 15 minus 9, which is 24, is equal to minus 10b. So b is equal to minus 24 over 10, which is minus 12 over 5. Then if we let x equal 2, that will make this bracket equal 0. If x is 2, 15 minus 6 is 9, is equal to 5a. So a is equal to 9 over 5. Now putting them in as the a and b, if you put a in as 9 over 5, you can put it in that numerator position, but it's going to be 9 over 5 divided by this denominator, which is the same as times in by the denominator. What happens is that 5 just joins in with the bottom. So I'm going to be integrating between 3 and 5 of my a, which is 9 over 5, 2x minus 4 minus 12 over 5, x plus 3. Now I can integrate, but before I do, I think I'll take the fact that we've got a 5 out on the front. So, oops, we've got the 2x minus 4 I'm going to put a fifth out on there, and now I will integrate. So keep my fifth, and the 9 is going to join in. I'm going to have ln of 2x minus 4, and then thinking about differentiating, when I differentiate the ln, you're going to get 1 over 2x minus 4, but then you times by 2. I don't want to have that times by 2, so I need to compensate and get rid of it on the bottom, and then minus 12 the ln of x plus 3. And that's between 3 and 5. Now putting my limits in, I've got my fifth there on the front. 5 in, it'll be 10 minus 4, it's 9 over 2 the ln of 6 minus 12 the ln of 8. And then the lower limit in, 9 over 2 the ln of 2 minus 12 the ln of 6. Now look at where we're going. We want some ln of 2, and we've only got this here. The ln of 6, so just this part here, can be written as the ln of 3 plus the ln of 2. The ln of 8 can be written as the ln of 2 cubed. So that 3 is going to come down and multiply by the 12. So we're going to have 1/5 and then 9 over 2 the ln of 3 plus the ln of 2 minus 36 the ln of 2 minus 9 over 2 the ln of 2 minus 12 the ln of 6. Now if I collect, that 6 one needs to go to 3 plus ln of 2 again. Now if I collect all the ln of 3's together, I've got 4.5 here, and I've got 12 here, and that's going to be a minus minus, so that's going to be a plus. So that's going to give me, the 1/5 stays out, I'm going to have 33 over 2 the ln of 3. Now the ln of 2's, I'm going to get 9 over 2, 4.5 ln of 2 minus a 36, which is 72 over 2, minus another 9 over 2. If you do all that, that comes out to be minus 48 over 2 the ln of 2. And then just take your fifth in, so it's going to be 33 over 10 the ln of 3 minus 48 over 10 the ln of 2. This next question has a trig identity, some integration by substitution, and parametric equations. So looking at part A, you get on the formula sheet that cos of A plus B is equivalent to cos A cos B, and then it's minus sine A sine B. So if we look at cos A plus A, in other words cos 2A, when A and B are the same, you're going to get cos A minus sine A sine A, which is the same as cos squared A minus sine squared A. And then using the fact that sine squared A plus cos squared A is equal to 1, sine squared A is equal to 1 minus cos squared A. So I'm going to sub that in for that sine squared A. So my cos 2A is equal to cos squared A minus 1 minus cos squared A. And then the minus here will make a plus, minus minus. So that's going to be cos squared A minus 1 plus cos squared A, which altogether is 2 cos squared A minus 1. Part B is the integration by substitution, being told to use 2 root 2 sine theta. Now when you're doing a substitution, you have to substitute for dx, what you're integrating, and the limits as well. So if we write that x is equal to 2 root 2 sine theta, then in order to get the dx on the go, we'll have to differentiate. Dx by d theta is differential of sine is cos theta. The 2 root 2 is going to just join in. Now, informally, although dx by d theta is not a fraction, we can just cross multiply and write that dx is equal to 2 root 2 cos theta d theta. So when we're going to substitute in for that dx, it's all of that expression that will stand for the dx. Let's have a look at the limits now. When x is equal to 2, 2 will equal 2 root 2 sine theta. Cross multiplying 2 over 2 root 2 is sine theta. The 2's will cancel and we'll get that sine theta is 1 over root 2. Now you might know your special triangles, that when you have 45, tan 45 is 1 over 1, and by Pythagoras the hypotenuse is root 2. Sine 45 is opposite over hypotenuse 1 over root 2. So you might just put that in your calculator and inverse sine, or you might know from your special triangles that the theta that will make that happen is 45. Now, whenever we're doing any calculus with trig, we have to be in radians, and we can see we've got a pi there, which is another clue, but theta will be pi by 4, which is 45 degrees in radians. Now, we do the other limit. When x is equal to root 6, root 6 will equal 2 root 2 sine theta, and then if we cross multiply again, root 6 over 2 root 2 will equal sine theta. I can rewrite the root 6 as root 3 root 2. The root 2's will cancel and I'll get that sine theta is root 3 over 2. Now the other special triangle is that when you have 30 degrees, sine 30 is a half. Here will be 60, the other angle, and then by Pythagoras, the adjacent to the 30 or opposite the 60 is going to be root 3. So sine 60 is root 3 over 2. So this angle in terms of radians is pi by 3. Okay, so we're ready to do our substitution. We're going to be integrating between pi by 4, pi by 3. We're going to do 8 minus, now x squared, if we square here and square all of that, we're going to square the 2, 4, square root 2, which is 2, they'll make 8, and then we'll have sine squared theta. And then substituting for the dx, we'll have our 2 root 2 cos theta d theta. Now we're going to take 8 out of here, which will be 1 minus sine squared theta. And we've got to square root that. Well, 1 minus sine squared theta is cos squared, so we're going to have 8 cos squared, so that will be root 8 and then just cos theta, and then we've still got our 2 root 2 cos theta. Pi by 4 to pi by 3. Now 2 root 2 is actually the same as root 8. If you think of that, 2 inside would be a 4, or you can just think of it that 2 times the root 2 will be all under the root 16. Square root of 16 is 4, times that 2 is 8. So this is actually going to be integrating 8 cos squared theta between pi by 4 and pi by 3. Now you might be thinking, well, part A hasn't really related to part B, and sometimes they do, but this is now going to relate, because how do we integrate cos squared? We use this identity here, so we just rearrange it to make that cos squared the subject, but I've actually got 8 cos squared, so if I just take that 1 over, I can write that cos 2 theta plus 1 is equal to 2 cos squared theta, and I've got 8 cos squared theta, So 8 cos squared theta timesing by 4 on that side will be 4 cos 2 theta plus 4. So this is the same as integrating between pi by 4 to pi by 3 of 4 cos 2 theta plus 4 d theta. Now we can finally actually integrate. So that's going to be 4 over 2 sine 2 theta plus 4 theta, which will be 2 sine 2 theta plus 4 theta. So putting our limits in, this is going to be 2, and then double theta will be 2 pi by 3, which if you think in terms of degrees is 120, and sine 120 is root 3 over 2. So we've got 2 root 3 over 2 plus 4 theta, which is 4 pi by 3. And then putting the lower limit in, pi by 4 doubled is going to be pi by 2, and sine of 90 is 1, so that will be minus 2, and then plus 4 lots of pi by 4, which will just be pi. So then the 2's here will cancel. We've got root 3, we've got plus 4/3 pi, minus a whole pi, which is 3/3, so that's going to be plus 1/3 of pi, and then minus 2. And if we take a factor of 1/3 out, you're going to get the pi, just putting it in the order of the question, plus the 3 root 3, and then minus 6. In part C, we've got parametric equations, and we're being asked to find the equation of the tangent at the point where theta is pi by 3. So to find the equation of a tangent, which is a straight line, we're going to be using y minus y1 is equal to m into x minus x1. So we need a point, and we can get that by subbing in pi by 3 into the xy equations, and we also need to differentiate. When you've got parametric equations, you make a chain. We need to find dx by d theta, dy by d theta, and make a chain. So let's do the gradient first. Dx by d theta. Now I've put over here the section from the formula book that you get the differential of sec goes to sec tan. So dx by d theta is sec theta tan theta. Dy by d theta. Now we're going to use the chain rule because this is a function of a function. Differentiating with respect to the outside first, ln will differentiate to 1 over 1 plus cos 2 theta, treating the inside as if it was just theta. Then we have to times by the differential of the inside function. So 1 plus cos 2 theta is going to differentiate to minus 2 sine 2 theta. Now we're going to make our chain. We want dy by dx, which is going to be dy by d theta times d theta by dx, because informally those d thetas will cancel and just leave us with what we want. So dy by d theta is minus 2 sine 2 theta over 1 plus cos 2 theta times, now d theta by dx is upside down of what we've got, so we need to do 1 over sec theta tan theta. Now using our double angle theorems, sine 2 theta is equivalent to 2 sine theta cos theta times by that minus 2 on the front will give us minus 4 sine theta cos theta. Now all the way through this question we've been using the double angle theorem that cos 2 theta is 2 cos squared theta minus 1, and we can see that that's going to be useful here again. We're going to have 1 plus 2 cos squared theta minus 1. We can see that's useful because the 1's are going to cancel, and then the next term will be 1 over cos theta, which is sec, times sine theta over cos theta. So we're going to times those two denominators together. That's going to be cos squared, and the effect, you don't really have fractions in fractions, that cos squared is going to go up there. So writing this out again, we're going to get minus 4 sine theta, cos theta. These ones will cancel. We're going to have just the 2 cos squared theta times a cos squared theta over a sine theta. So the cos squareds top and bottom will cancel, the sine theta will cancel, and the 4 and the 2 will just cancel and leave us 2 on the top. So dy by dx is minus 2 cos theta. So now we're ready to find all our bits to find the equation of the tangent. So when theta is equal to pi by 3, dy by dx is equal to minus 2 of cos of pi by 3. Now pi by 3 is 60, and do you know your special triangles? 30, sine 30 is a half, so cos 60 is the adjacent, same number 1 over 2, so cos 60 is a half, so that's just going to be minus 2 times a half, which is minus 1. X is equal to sec pi by 3, which is 1 over cos pi by 3, which again is 1 over half, so that's just going to be 2. Y is equal to the ln of 1 plus cos 2 pi by 3. So if pi by 3 is 60, double that's 120. And if you think about your cos graph or your CAS diagram, the 60 gives you the half, and the 120 gives you the minus a half. So cos of 120 is minus a half, so this is going to be the ln of 1 minus a half, which is the ln of a half. I'm going to write that as the ln of 2 to the minus 1, and then bring that minus by my log law in front. It's minus the ln of 2. So now using my y minus y1 is equal to m into x minus x1. Put all the bits in. We've got y minus the ln of 2, which will be y plus the ln of 2, is equal to our gradient minus 1 into x minus 2. So just multiplying that minus in, you're going to get y plus the ln of 2 is equal to minus x plus 2. I've selected this last question, a modelling question and linearization. This seems to be a particular favourite of the exam boards at the moment, so I definitely do some of these type of questions. So we've got in this case an exponential model, p equals ab to the t. I can see it's exponential because the unknown is in the t. A and b are just constants. So you get the linear model by taking logs. So if we write p is equal to ab to the t, taking logs to both sides. And because these two are multiplied, they can separate with a plus. So it's log a plus, and then the log law, the t can come down, t log b. So this is now of the form y equals mx, because remember t is the variable, plus c. So the log a is the same as the y-axis intercept, and the log b is the same as the gradient. Now sometimes you also get a model, if we had p is equal to a t to the b, where the variable is on the ground, that's a polynomial model. You could take logs to both sides, and similarly this would be log a plus b log t. So the variable is t. Sometimes you log both of the variables, and sometimes you just log one. But in this case here, which is not what we've got in this question, the b on its own would be the gradient, and we'd have to have log of both variables on the axes. But that's not what we've got in this question, just thought I'd mention it here. We've got to now try and write in the equation. That's what I've just written here. This is the equation. And now we've got to try and find a and b. So we're looking at the y-axis intercept to try and find a, and we can see that the y coordinate is 5. So 5 is equal to log a, because when t is 0, this term will go out, And so what we can do now is just say 10 to the power 5 is equal to a. If you remember the way logs work, 4 cubed is equal to 64. Another way to write that, log to base 4 of 64 is equal to 3. So 4 cubed is equal to that. I've got log to base 10 of a is equal to 5. 10 to the 5 is equal to a. So a is equal to 100,000. 10 to the 5. And now finding b, well, we can see, because we're told that the gradient is 1 over 200, that log b is equal to 1 over 200. So doing that same pattern, 10 to the power 1 over 200 is equal to b. And if you do that on your calculator, b comes out to be 1.012. Now having a look at part C and part D. In part C, you're asked to interpret the constants A and B. Now, whatever exam you are doing, stats, pure or mechanics, when you're asked to interpret, you must talk about the variables. You must put the A back in the context of the variables. So A was equal to our 100,000, and that was at the point here when t is equal to 0. Well, that is going to be at the point when we started recording the data. So A is equal to 100,000 is the initial value of the population at start of the recordings. Okay, now it's asking us for B. B is equal to the 1.012. Now our equation is that P is equal to the 100,000 times the 1.012 to the t. Now if you remember when you used to do compound interest, and this bit here would be 1 point something, and this, the point something, was always the percentage increase. So we can see that this population is growing at a rate of 1.2%. So the B, because we've got this 1 as well, B is proportional to the rate. Of increase in the population. Okay, let's have a look at D. Find the population predicted by the model when t is 100. So P is going to be the 100,000 times the 1.012 to the 100. If you do that on your calculator, it comes out to be 329,648. It's asking us to the nearest 100,000, so that's going to be 300,000. And then in part 2, the number of years it takes for the population to reach 200,000. So 200,000 is going to equal our 100,000 times the 1.012 to the t. And we've got to now solve for t. So if you divide by 100,000 and then take logs, log 2 is equal to t log of 1.012. Divide by the 1.012, t is equal to 58.1. So if t was 58, it'll still be under. It's going to take a little bit longer than 58 years, but t is equal to 59 years, and then the population will be over the 200,000, or at least reach it. State 2 reasons for part E why the model might not be realistic. Well, one reason is that this model just predicts that the population is going to increase forever, so may not increase indefinitely, and also the rate may not be constant. Well, that's it for this video. Thanks so much for watching. If you're still with me at this point, do check out the channel because I'll be uploading some more on the run up to the exam, more help with pure and then some help with the applied as well. Do like and subscribe. I hope you found the content of this video useful and helpful. Good luck in all your exams this summer, and I'll see you on the next one.